will deal with the introduction of the control systems. So what are these control systems? Control system is nothing but it is a system that regulates or commands other systems or the subsystems, that is to obtain the desired objectives. So these play a vital role in our day-to-day lives. So not only in the domestic domain but also in transportation, in space technologies, also in the industries. These control systems have gained wide importance, because we can see everywhere whatever we use we can come across this control systems. So our human body, this is the best example for the control system, because we have pancreas that regulates the blood sugar. Likewise our eyes, okay, it will be following the moving object, so that just to keep it in view. Okay, and not only that, our hands also, if I grasp this object, what I will do automatically, what we will do, we will try to place this at the predetermined location. So our human body is the best example for the control system. Fan, you have a regulator, so what you will do, you will set the regulators to the speed 5 or 4, and accordingly what happens, it starts rotating. So fan, okay, this is also an example of the control system. Whatever the refrigerator you are using, washing machine and iron box, and automatic tea or coffee maker, toasters, these are also the examples of the control systems. So we have a manual control system, we also have the automatic control system. Manual and automatic control system. So manual control systems are those control systems where human being is operating or he is controlling the actions. But if it does not involve any human being, then we can call it as a automatic control system. So if this is the control system, this is the input, this is the output. So input, this is also called as excitation. It is also called as desired output. What about the output? It is also called as response, or we can also call it as actual response. So input, whatever the input you are giving, according to that what happened, we will be getting the output. So certain objectives are met in this case of control system. So for example, I can consider car. Okay, in that car what happens, the pressure that you are giving on the accelerator, okay, pressure you are giving on the accelerator, that will be your actuating signal, or it can also be called as input. Okay, and what will be the output or the desired actual response, that will be your speed. Speed will be the output, or it is also called as controlled variable. Controlled variable. Similarly, we can also consider the direction of steering wheel. Direction of steering wheel as input. Direction of the vehicle, it will be your output. So in which way you are turning your steering wheel, in that way what happens, your wheel, okay, front wheel starts moving, right? So that will be your output. So this is input, and what happens, you are going to get the output. So this is also an example of the control system. And next example I can quote as this as elevator. So next example is elevator. What happens when you get inside the elevator? You will press the second button, that is the second floor button, and what happens, you go and that lift stops at that particular floor. That will be your desired output. Pressing the second floor button, that will be your input, and stopping here, that will be your output. And next you can see that all these manual control systems, these are best examples of the open loop systems. Open loop systems. And next category will be your closed loop system. So best examples will be manual control systems. So best example for this manual and automatic control system is your water tank at home. So what happens, there is a water tank. Okay, so now what happens, your water will be, okay, the water level will be starting to increase. You will switch on the pump. Okay, pump, then what happens, your water level starts on increasing. Here a person is standing and here he is monitoring the water level. Okay, so this one will be your, and what happens when it reaches this desired level, he comes and he will be switching off the pump. Okay, so this one is your manual control system because a person is involved in this case. But similarly, what happens if I replace this operator, this person now, okay, with sensors and controllers, that becomes your automatic control system. So what happens, I will be placing a sensor in the water, okay, and there will be a microcontroller, okay, which will be controlling all the operation. So what happens is, when it reaches a certain level, the sensor, it sends the message to the controller and it switches off this pump. And again what happens, you start using the water, again the water level starts to decrease, and here you think that there is a certain level and it has reached that particular level. So when it reaches this certain level, again sensor sends the signal to the controller and it turns on the pump. Okay, so again it fills the water. So here what happens, there is no need of manpower. Here we need not go and stand near the tank and monitor this levels of water, right? So all the work is done by the sensor and the controllers. So this is an example of the automatic control system. So we have this open loop systems and the closed loop systems. So manual systems, these are the best examples for the open loop systems. So for example, I can consider automatic washing machine, automatic toast makers, automatic tea or coffee maker, traffic light, so these are examples of the open loop systems, where what happens is your control action is independent of the output. That means you are not going to give any feedback signal. There is no measuring of the difference between the output and input takes place in the case of open loop system. So whatever you are going to give the input, you are going to get the output. Okay, so there is no control, means controlling action is independent of the output. So that is what, okay, control action is independent of the output. It does not depend upon the output. So you can see that automatic washing machine, you might be thinking that this is a closed loop system because you will just on and everything will be done by the machine. But no, this falls under the category of the open loop system. This is not the closed loop system because it works only for the preset time period. That means if I set the washing machine to 10 minutes, it will be operating for 10 minutes and it will be off after 10 minutes. So irrespective of whether your clothes are washed or not, it doesn't care whether your clothes are completely cleaned or not, it will just use this preset time. Okay, so it only runs for 10 minutes and then it stops. So this falls under the category of open loop systems. Toast maker and tea coffee maker, traffic light also. Traffic light means you can see there from 60 it starts counting down 59, 58. So it will be set to 1 minute. So there is a preset time period. So this is also an example of the open loop system. Closed loop system means what happens, you will get the output and it is again fed back to the input. Here you are getting input. The error is error, it is measured here. Error, that is between the output and the input, what is the difference, it is measured, and again it takes the necessary controlling action and again it tries to achieve the desired output. So best example for this closed loop system will be your air conditioner, iron box, electrical iron box, refrigerator, water level controller. So these are the best examples for the closed loop system. So air conditioner, why? Because now what I will do, I will set the room temperature to 21 degrees Celsius. Yes, it takes some time to set to this 21 degrees Celsius. So directly it does not reach 21. There will be some transient response and finally it will be reaching the steady state response. So after that what happens, if there is a slight change in your room temperature, if the temperature decreases or temperature increases, accordingly it will be setting to 21 degrees Celsius. So there is a feedback action which is going on in the air conditioner. So that is why it is classified under the closed loop system. So electrical iron box also. So if I set this to the silk, okay, so there is some temperature, right? So if it starts cooling down, to maintain the temperature, again you can see that red light means it will be on now. So it will start heating. So that's why electrical iron box is also an example for the closed loop system. Refrigerator also, it will be maintaining the temperature throughout. Water level controller, as I just explained, okay, the sensors and the controllers will be doing this all work, okay, of the operator. So water level controller is also an example of the closed loop system. So for a good control systems, there are some criteria that should be satisfied. So for example, it may be accuracy, sensitivity, bandwidth, noise reduction, and the stability. So sensitivity, a good control system, it should be sensitive to the input but not to the parameter variations, like the environmental changes may affect the control system. So it should be not sensitive to these parameter variations, but yes, it should be sensitive to the input. And next is accuracy. Yes, a good control system will have a very high accuracy rate, okay, because you can consider the example of the lift. That means if I press the second floor button, what happens if it goes and stand in middle of the first floor and the second floor? Either you have to jump up or you have to jump down. So that means that, there is no accuracy. So accuracy, steady state is very important in case of the control systems. Next, speed. Yes, it should be having the higher speed, because if it is very slow, then obviously what happens in the case of lift, you can consider what happens if your lift is very slow. That means to reach the second floor from the ground floor, if it takes 10 minutes, won't you be frustrated? Yes, you will be frustrated. So the passenger will not be satisfied in this case. Okay, so even the speed should be high. Next, noise. It should reduce the noise effect. Good control system should reduce the effect of the noise. Next is stability. Yes, for all bounded inputs, you should have the bounded outputs. If your input is 0, the output also should be 0. That is your stability. Then you have bandwidth. For a good frequency response, the bandwidth should be large. So in the case of lift, if I consider this as a ground floor and if I consider this as second floor, after pressing the second floor button, it takes some time and then it starts. So suppose this is the steady state error. The difference between this and this, it is called as error. And this is your steady state response. Steady state. This is your transient response. So transient response, this one will be your temporary response. This is also called natural response. And this steady state response, it is your permanent response, or it is also called as the forced response. So this accuracy should be very more. So in case of lift also, you should have a high accuracy rate. That's why I told what happens if your lift goes and stands in middle. Okay, and what happens if it takes 10 minutes to reach the second floor. So that is what it is determined by the transient response. Okay, and oscillations. Next it comes oscillations. Oscillations means this should be very less. That means when t approaches infinite, it should be your natural response should decay. It should become zero. Otherwise, there will be oscillations. What happens if your oscillations doesn't stop? If your if the natural response is greater than the first response, what happens to your lift? Either it will be crashing to the floor or it will be going above the ceiling. Okay, that is what going to happen if this is not in control. That becomes means that makes your system uncontrolled. System will be unstable. So oscillations should be as minimum as possible. So as t approaches infinity, what happens? It should be natural response should be 0. Then only your system will be controlled, or it can be called as a stable. Okay, so this is an example of the lift or elevator. So this is also a control system. So this is the classification of control system, like manual and automatic. And again we saw about the open loop and the closed loop systems, and we also see we have also seen like what are the criterias that should be satisfied by a good control system. So these are the important parameters that one should remember.